Good evening, everyone. Hello. Um, just to let you know, I've just posted a link in the chat to our May meeting, which you may want to take notice of because we've actually got someone who ran Acorn's Palo Alto Research Center going to be talking to us about ARCs, which was the original failed Archimedes operating system that RISC OS replaced. We've only previously heard from all the RISC OS people about it, so hopefully we'll get the other side of the story. So yes, do follow that link, read that later. Don't read it now because you're going to be listening to Matt instead. I think that's what I've got to say. I'll hand over to Matt. Take it away.
Thank you very much. All right. Thank you. You haven't done anything yet. You're very easily pleased, aren't you? If you've got questions from at home, do put them in the chat. We're going to hopefully someone can read them out and interrupt me. And obviously, you lot here, you're charged with interrupting me as much as possible because otherwise you have to put up with my crappy slides. So that is the way we're doing this today. Cool. Yes. So, coming up with names is really hard. Naming is very, very difficult. So this is a terrible name. We're going to ignore this, but I'm going to kind of explain a bit about myself and then a bit about all of the various Acorn related things. And then it's kind of at the end, tie it together as like, it's kind of the conversation we were having just a minute ago, like everything I did in my Acorn days led to me doing the job that I'm doing now. And the other thing that I know some other people are worried that may be interested in. So let's get going. So of course it's not going to work, my clicker. Let me just click there. All right, let's try again. Yay! Okay, who am I? So this is a picture of me, circa 1980, 88, 89, I think. And my poor sister is unfortunately in the front there. So she bears the brunt of this one. But this is the earliest picture I've got of me and a computer. You may notice that is not a BBC Micro, and I'm very sorry. I know. Well, Anti-Mike season is way, way beyond that. So yeah, I started on a Spectrum. It was a 48K Spectrum, and later I upgraded it to a +3, which is a really posh one with a disk drive. I believe it probably fell off a lorry because there's no way I don't think my parents could really have afforded one of those, but I was very lucky I had it. My story started actually when I was about 7. I apparently went round to a friend's house and he had a Spectrum and he was showing the flight simulator, which if you recall was something just a bit like nowhere near as good as Aviator, but like just a plain line for the horizon, and then if you were lucky and you actually found the runway, the square of the runway, and you would try and land a plane. And of course, 38%, not 38, 97% of the screen was in fact cockpit, so that they only had to draw the 3 pixels for the rest of it. But so my dad was interested in that, but then my friend kind of showed a type-in program and ran it. There were just numbers going up the screen. And my mum tells me that I was absolutely captivated by the numbers on the screen, and they knew that was probably the path that I was going to go, and they were right. So I did upgrade, though, to a proper computer eventually. So the BBC Master around whenabouts? That would have been just at the beginning of like, I'm going to say high school. Oh dear, I'm so sorry. Around that time. And with a friend, I wrote a bunch of games and typing listings and sent it to the variously named Dave Acton, Dave Lawrence, Acorn User. What was it called? Was it Star Cats? No, what was
Star Info.
Star Info. Thank you in the back there. Star Info. So that was great because when you're 15 and 16, then you're getting 10, 20, and even £50 for a single type-in listing. That's a lot of budget games. Although of course, whatever. And then in 6th form, I got to an A3010, so we know a proper machine. Now we're into the Rugol part of this. So I'm just making sure that I'm just presenting my credentials. And later on, I got a RISC PC at university, which was great. So I had a RISC-P 600, RISC-P 6, well, whatever, the one that had the ARM 600 in it, I forget the actual number of it. And then my housemate got himself a strong ARM for his ARM 700 base system. And so I inherited his ARM 700 from him. And that was a massive upgrade. The Acorn User here. So if anyone ever remembers this is a Julia set program. That is in fact me and my friend Richard Tubble-Watkins, who we'll speak more of later. And this apparently, and Matthew Godbolt. So for all the misspellings that we were talking about earlier of my last name, this one followed me around for a long while. Yes, so that was fun. This one was the Star program, so this was 50 quid's worth of program. And at the time, I believe it to be the fastest Julia set generator for the BBC Micro, but I don't know that there were any other ones. So there you go. So yeah, as earlier, my friend Rich TW, who I met up with this weekend, that is us there at ABUG only a couple of days ago. I met Rich doing walk-ins like the first day of school, and we became friends immediately. I remember leaving my previous school. I remember telling my mum that I was really upset because no one would be good at computers, unlike and I found someone at that school who was good at computers, and I met Rich on the first day, and it's like, oh, I'm going to be fine, And so we've worked on a whole bunch of stuff together. The Acorn User stuff. Frogman's not actually Acorn User, but we were actually putting together a multi-part game called Onslaught, which was a sideways shooting, jump around, shoot things, loosely based on a Sega Master System game called Onslaught. It was a 3-part series for Acorn User, and then it was so late in the day. Eventually, we got a letter through saying, look, we've stopped doing the BBC micro stuff. The 8-bit stuff's gone now. Sorry. And that was signed by Mark Moxon, who now is like, it's so weird how all these things come together. So that was a really nice thing to meet the man who signed a thing in like 1995? No, more then. Oh gosh. And then Frogman was a game that Rich and I were putting together for Superior Software, and I have a nice rejection letter from them because, and as we played it this weekend at ABUG, they were not wrong to reject the game, but nevertheless, you can go see it. Then at my Archimedes stuff, Rich and I worked on a game called Blurp, which is essentially the port of Onslaught to the Archimedes. Never quite made that either. There's a bunch of levels, a level editor, and a whole bunch of cool things with it, but we didn't really know where we were going with this. Mostly Rich actually wrote the Sega Master System emulator, which was fast enough to run on his ARM 250 on his A3010, which is no mean feat at all. So we called it Miracle because it was a miracle it was that fast. Rich, some of you might know he wrote Beeb, or at least the original version of it. He then also ported back Blurp to the BBC Micro, which you may think, well, hang on a second, this is the same game 3 times. Yes, and so there is now a BBC version of Blurp. We played again that this weekend, and that one we should release because it is good enough. It's hard, but then games are hard. Somebody else in this room, Dominic Holton, knows Rich TW as well because we all went to the same school, the Howard of Effingham, which I'm sure you're very well aware of at the front here. Yes. So 3 Howard of Effingham alumni are involved in this. So Dominic, I will not mind me saying, he's youthful in comparison to me. By 2 or 3 weeks, we straddled the boundary. The year group. Yeah. So my birthday's in August. You're in September, so you were in the year below us. Although now it all rounds to 0, doesn't it? These differences, right? And so, we would frequent the lunchroom at the Howard of Effingham and play on all the BBC micros that were networked around us. So that was fun. All right, Archimedes era. Did anyone ever use FinalLook or know what FinalLook is? No. Well, you did. Well, of course you did. I know you did, but yeah. Did anyone ever use IRClient, the IRC client for RISC OS?
Used one of them, but I can't remember.
Right, you don't know which one it was. Okay, and then Miracle we talked about before. Yeah, so FinalLook was a RISC OS 3.5 backport to RISC OS 3.1. Now I know you could go and get the ROMs and you could load them in, RM load them in, and get like the nice fancy backdrops and the nice anti-aliased fonts and a few other bits of the nice window decorations and things like that. But you were then essentially taking 90% of your ROM and loading it into RAM just to have it slightly different. And I didn't like that because I didn't have enough memory for that and to actually use it as a computer. So I set about trying to achieve the goals of what the 3.5 sort of WIMP looked like, but in the cheapest possible way. So I hooked every single SWI, and then every time a SWI came in, I was like, where did that come from? And I scoured the ROM for places where it was using a SWI, sometimes on purpose, like it was an Oz right char or something. And I was like, oh, I can grab that. That's the one that's actually writing the letters of the WIMP. Other ones, it was just the nearest one I could possibly find to a bit of code I wanted to patch to put something in there. And then I would duplicate all of the rest of the code that was in ROM in RAM, do the extra bit, and then jump to the bit of the ROM that would carry on from where we left off. So background tiles, fonts, etc. It just worked brilliantly. It's an absolute testament to how hackable the BBC Micro and Acorn sort of suite of computers were. It was just fabulous, the fact you could do this. And obviously no memory protection or anything like that was also helpful. And the fact that you could just take the one, like a CPU's like interrupt handler away from it, like without any, I was we're safe, you know, but then you can just always enter us, which is like the funniest thing ever. Like just anyway. So that was cool. So a shout out to Robin Jubber, who was also at ABUG. Robin Jubber is somebody I worked with at the first job I ever had. But we didn't know this until I took this screenshot many years later. You can't probably see it here, but the author of the configuration app, there's a WIMP app that configures which tile statement that is in fact Robin. He sent me it when we were both at university, and you know, in the good old shareware ways, we put it in, and it's only many years later that we discovered, wait a second, there can't be that many Robin Jubbers in the world. He told me this weekend there actually is one other one, but it was in fact.
He has been here as well. Yes,
I figured he might be, which is why I thought I'd put a shout out. Otherwise, you know, I'd get an evil look from him. Fabulous. Okay. Final look. Yeah. So there's some horrible bits of code there. I've actually got a blog post that explains some of the tricks that it was doing. Hookable. Yeah. Try doing that on Windows. There's a blog post I've written about it 20 years on. I actually found the source out and decoded it. So it's all. I'm trying to put loads of stuff up on GitHub these days, just so people can have a laugh at it. If only, just I don't know if that. No, that one's got some sensible names. If you look at some of the other sources I've got, it's like, you know, whatever happened at 3 a.m. that made me think that was a perfectly valid label name for some opcode. But yeah. Anyway, IRClient. So this was one of the IRC clients. Everyone else was using. You know, there was MIRC on Windows, and there was IRC on the Unix command line for most of the chatting. So this is the Internet Relay Chat, for those who don't know, sort of very early federated chat client come chat room type application. And this one was, early mid-90s. And they all had scripting languages because you wanted to, although it was just a chat client, there was this concept of whoever was first in the channel kind of had some kind of privileges, and then you could give those privileges to other users, and then people would write these sort of like bot accounts or script their own accounts so that as soon as they joined, it would send a message to one of their mates who would give them the operating privileges or whatever, or you know, the list of people who would join the channel that would have privileges would be given it. So I thought, well, I'm going to write a script language for this. I'm going to write it in BASIC, right? But I'm not. So the whole thing, by the way, this IRC client is 100% assembly code, right? There's no C or anything in this, which is like the largest bit of C assembly I've ever written. And then, to make it compilable and scriptable, I wrote my own language, IRBasic, which I was sort of, so I did a physics degree. I didn't actually do any computer science stuff, but I had friends who were doing computer science related stuff. So I kept hearing ideas from them, misunderstanding them, and then applying them to what I was doing, which I think, you know, we call it exploration. So it became object-oriented once I learned what object-oriented was. And I had this problem where I didn't want to free things after I'd allocated them or created these little objects. You know, once you've got like classes, you know, instances of classes, you know, you've got like a list of users and whatever. And I kept having to either work out when I needed to free them or whatever. And so I came up with this really clever way where I could walk through memory and tag all the things that I could find, and then follow all of the links between them, and then tag them as being used, and so on and so forth. And then at the end of the day, if nothing was left tagged, it obviously wasn't being used by anything, and I could throw it away. And I was so pleased with myself. And then my friend Malcolm said, "You've just invented garbage collection." I'm like, Mark Sweep garbage collection. So I thought I was very clever. So Jeff, who I'm sure you're all aware of. Hey. Jeff is a very smart person. I don't believe I ever publicized that IRClient had this scripting language in it. It was really for me to start writing bits in it. But Jeff found that it had this sort of BBC Basic inspired language in it. And then before I knew it, he'd essentially written an entire operating system, much like Emacs is an operating system inside a text editor. Jeff had written a web browser, as an SMTP client for email. I think there's a law, isn't there? There's someone has got a law, Wachowski's law or something like that. It's like all non-trivial programs grow until they can send and receive email, and that was definitely true of IRClient. So huge shout out to Jeff. He and I became fast friends, and like during the summer months we would spend a bunch of time at each other's houses, and you know, which was fabulous, absolutely fabulous. So hi mate. Shareware. It was shareware. It was £10 to register a copy. And in fact, I loaded it up the other day and I quitted it, and it comes up with this big thing saying, you know, like, oh, it's only 10 quid, you know, register this version of it. And I'm like, oh. But it kept me in beer money. Again, 10 quid goes a long way in 1994. So, yeah. The source for this is on GitHub, and it has some absolutely hilarious things label names. Womble Loop Jedi is my favourite label name from that. And what was the other one? So Jerf, you, if I remember rightly, so Jerf used to have like a list of quotes. Oh, it's my phone saying it's 8 o'clock. Sorry. He had a list of quotes that he would tag at the bottom of all of his emails, and one of them was, oh god, he'll probably know what I mean. It's like worm tablets or something at line 10 or something. Anyway, it was some other thing. He came up to him and he thought it was funny enough to just leave it as like a little like choice quote. All right. What happened next? Okay, so then after that university, I took advantage of my physics degree to the nth degree by ignoring it and never using it, which I think is the way you do with degrees these days. And I went and worked in the games industry. I worked on some Dreamcast games. Croc Legend of the Godbolt is probably the only one that anyone might have heard of. There's a few noddings. Hallelujah. Red Dog. Nobody had a Dreamcast. I'm so sorry. It was dead on arrival. It was a beautiful, beautiful console. And if we want to do an auxiliary hour on why it's the best console that ever existed, we'll do that afterwards. And then I did SWAT on the Xbox and PlayStation 2 and some other bits and pieces as well. Then I ran that Argonaut Games. So Argonaut Games was the company that developed the Super Effects chip, which some of you may know from Star Fox. So they have a similar kind of genesis story almost to ARM and Acorn, because they budded off that technology company that actually did quite well and actually ended up in a whole bunch of switches along the way. The Argonaut RISC core is what it was, so it even sounds a bit like ARM. But then unfortunately, the games company went bust along with a load of other games companies in the mid 2000s or early 2000s. And a friend and I started a company because we saw this massive bunch of C++ code that was just unwieldy and impossible to deal with and too complicated. And we thought we're going to solve C++ compilation and building. And we weren't very successful, as you can probably tell, but that was Profactor. And that friend actually, by an amazing coincidence, actually works with Kieran these days, which is like hilarious that the world is that small. Then I went and worked at Google, a couple of years at Google, which was a lot of fun. Definitely recommend doing YouTube mobile type stuff. So effectively it's a continuation of the gamesy stuff. Then I moved to trading, which we talked about to death a little bit before we started here, so I won't go over it again. I ended up in Chicago and I've been in trading ever since. Okay, and I'm currently at Hudson River Trading, which I put on there because if you're interested in doing trading, talk to me afterwards and I can talk to you about a career with anyway. But so now we're back to Acorn stuff. So that's where I am now, right? I've been 15 years in Chicago. I missed something. I'm sure that's talking to a room full of people who also feel like they're missing something and they want to recapture something. And that itch started, it's scratching, whatever, what's the word? Itching. It sounds, but I've said the word itch. It started happening in like 2011. So I just moved to Chicago and then with two young kids, it was my wife's mother's 70th birthday. We were living in like a corporate apartment, so we didn't even have any of our stuff. I just had a laptop and me, and I don't think we even had a TV. And it was her mum's 70th birthday, and so she was like, well, I'm going to fly back for that. She took the kids. So what do you do when you don't know anybody in a new city? You've just started a new job and you don't really know what you're doing there, so you don't have much to do. And you've got all this spare time in your hands. Well, you take your ARM-based Sega Master System emulator and you port it to JavaScript, obviously. So that was something I did for a laugh. So the Sega Master System was an 8-bit console. I think in this room and probably online, everyone knows what it is. When I talk about this kind of stuff in the States, the Genesis, the 16-bit console, was the one that they remember and they know. And then they only really remember the NES, the 8-bit Nintendo. Sega dropped the ball on that. You can get them. I have an American Sega Master System, but that was my childhood console growing up. Due to a mix-up, my sister and I were on a ferry to France, and you're bored. You go in the arcade. There's all the games there. We saw Altered Beast, and we thought this is amazing. And I misinterpreted the fact that if I saw this game Altered Beast, I saw you could get it on the Sega Master System, and it would look the same. And it's very underwhelming.
But you have to be used to that. You're on Spectrum.
That's true.
Screenshots.
That's true. No. Yeah, I mean, but yeah, he is. Yeah, you're not wrong. But yeah, so the thing about JavaScript is it was a bit of a joke I was doing it for a laugh and I was learning it. I didn't really know what I was doing, but it turned out to be remarkably good, even in 2011, at emulating a system. Now, of course, you're talking about a 2 gigahertz laptop, but it's an interpreted language running in a web browser, trying to emulate a system that ran at 3-4 megahertz and had like a VDP, equivalent of a video chip and sprites and things. And like, hey, this is all right, So obviously, the next step is how hard would a BBC Micro be? It should be easier, right? Well, yeah. So the thing about the Sega Master System is that people in the games industry will know is that like the companies who make the hardware have very strict rules about what you can and can't do with their hardware, and they have a whole bunch of tests and quality control that make sure you're not doing things that you're not supposed to. There is obviously no such thing on the BBC Micro. It was a wild west of doing whatever you liked. If it seemed to work on your BBC Micro, then it would probably work on everyone else's. Probably. Obviously, I think we've all got stories of incompatibilities, but yeah. So we all know what JSbeeb looks like. It's this. This is the debugger, by the way, which is incidentally, if you ever write an emulator, invest the time in writing a debugger because you're going to be looking at an awful lot as you're trying to debug 1980s games that you don't have the source code to, while you're trying to work out why it's not doing the thing that you're expecting it to. And I mean, it's always your fault. Except there was that one time, I think was at Sarah's, there was a VBlank, an interrupt, and there was a one cycle spot where the wrong ROM was paged, and if an interrupt happened, then it actually did crash. It was reproducible on an emulator because it was 100% reproducible, but on a real machine, it would never happen. Anyway, almost always, it's your problem. It's like compilers. I don't know who among you writes compiled code, but you're like, there's a bug in the compiler, and there's almost never a bug in the compiler, except when it is, and then it's really bad.
Except if you the compiler.
Except if you really, yeah, that's even worse. You're like, what idiot? Oh, yeah. So what makes emulating a BBC Micro particularly difficult? Well, if you're going for full emulation and full support of all software, then that's what gets you there, right? And that's what I really wanted to do, is I wanted to make sure that my emulator was as accurate as can be. Obviously, I'm standing on the shoulders of giants, like Sarah's emulator and various other emulators. They're out there, the source code's out there, and I could use it as a reference. And I did liberally use these other emulators as a reference, but some of them had some weird fudge and bodges and things, and it's like, this is required to get this game to load. It's like, oh, I don't like that. I want to know why it's not loading. So yeah, obviously cycle accurate 6502, which is more difficult than you might think. The 6502 is a damn simple device, 3520 transistors, something like that, hand laid out. I still love that there's a grainy photograph of a bunch of middle-aged pipe-smoking men with weird slippers on, walking over an acetate sheet the size of this room there's a Sharpie effectively drawing the damn transistors. And as I understand it, the sort of solution for it, taking that and actually fabbing it, was something along the lines of hoisting a camera as high up as they could and taking a photograph of the whole thing and then doing that a few times, which just is mind-boggling. So the 6502, I'm sure, as even if you're RISC OS people, you understand the purity and the beauty of the 6502. But what makes it difficult to be cycle accurate is that you could look at an instruction and go, well, this is a rotate left to some memory address, and it takes 7 cycles. Great. Okay. So I just rotate the memory, say 7 cycles have moved on, and then get on with my life, right? Except no, because reading and writing to memory has side effects on these computers. Hardware is memory as far as they're concerned. If you read and write to, say, a timer, reading from the timer might reset it, might start it going again, or writing to the timer certainly resets the value that it's counting from. Now, when you're talking about these timers, they're running while the instruction is going. So during those 7 cycles of a rotate, you don't know, it's not documented, where the read happens and where the write happens. One of those cycles is reading, one of those cycles is writing. And now most of the time it doesn't matter. If you're trying to get Kevin Edwards' code to work, you need to know where the thing. So, and then obviously the Beeb has cycle stretching. So when contemporary 6502 based machines would just run at 1 megahertz and be the same speed as the peripherals, whereas we obviously would run at full speed, but then we'd have to slow it down every time the Beeb tried to access, FE00 or whatever. So, but there's a kind of problem there, because what do we do when you're in an even or an odd cycle compared to the peripherals? What does it do? Does it wait 2? Does it wait 3? And how, or 1 or 3? Or how, how does it get in phase and how does it recover from that afterwards? Luckily there are circuit diagrams. And even more like, oh no, hang on, sorry, I forgot which order my slides are in, which is no supposed, even though I have them down here in front of me. I'm not looking at that. I'm at Burke. Obviously, video chip is fairly well understood, although Kieran and his buddies keep finding new ways to make it do things that I didn't know it was possible to happen. And I still think there are a number of things that don't work on JSbeeb, right? And here I am trumpeting how accurate it is. But Beeb chip is probably better at the CRTC. The sound chip is reasonably well understood, although we still keep bumping into things that are not quite well understood in terms of how long you can leave the gates and things open while you're writing to them, or whether you have to, in fact, reset them between reads and writes and things, which, again, demo writers like to take advantage of and then don't work on JSbeeb. Disk controller, I mean, there's a famous thing that Scary Beasts and Co. have actually well, that was that the 827 or was it 1770? It was the 827, yeah. So a mutual friend of ours has reverse engineered the 8271 to the point of like taking the top off the chip and finding the ROM inside of it and realizing that it actually is an Intel microcontroller and a previously undocumented Intel microcontroller amongst the friend group, including Rich TW, reverse engineering the instruction stream and then working out what all the routines were doing. And like, unfortunately, they've not been able to find a way to like execute arbitrary code on it, but otherwise that would be super cool. Then we could feel as cool as the Commodore 64 people who brag about the 6502 on their disk drive, right? I think we know what the games look like, but obviously Exile is the best game. I will take no further questions.
Correct.
All right, okay, we're among friends here. How do you know it's right? Well, there is a test suite. Thankfully, other emulator writers have really come together and come up with a really comprehensive set of functional tests. These will not test if your cycle counts are right, but they will test if you've got all of the weird binary coded decimal side effects down pat, which is another whole thing. Visual 6502, I'm sure you're well aware of this. This is, I think, was Ed Fizzles involved in that? I think he was actually, yeah. But yeah, this is the die shots of the 6502. This is why we know that exactly how many transistors there are, and it is a beautiful thing to go and look at, which I'm sure you've all done here. So it's and then the real way you know it's right is when Kevin Edwards' protection systems boom, and you don't have any special checks for like if the address is this and this byte is this, then take 2 more cycles for reasons we don't understand. For that, I must give full credit to Richard Torber-Watkins for sitting down and working out all of the possible combinations and permutations where the reads and writes could happen. We knew when they were happening because on the Visual 6502, we can see which cycles the bus gets activated mid-instruction. But then we needed to know how that interacted with the 1 megahertz bus peripherals and the cycle stretching. And so he wrote a whole bunch of like spreadsheets and with all where the things would all not line up. And then he got, I think Ed Spittles actually was the person who ran all of the tests on the real machine, and we got the answers, and then he was able to come up with a kind of comprehensive theory of how this works, which boils down to like 2 lines, which is not that surprising, but it was great to get there in a very empirical way. Yeah, if nitrous shade boost, you're good. Something that I did recently, which you may not have seen before, is, we love our Cub monitors, right? They are the sort of the perfect way that we experience our BBC Micro. But actually, I don't know where my mouse has gone. There it is. Actually, this is more like there we go. This is more what I saw when I was growing up. So I now have a somewhat authentic PAL emulation. There are definitely problems with it, but if you're close enough that you probably can't. Unfortunately, we're now all of an age where that looks perfectly good, right? It just looks like a normal image. Damn it. But the colours are weirder and it's hopefully more authentic. There is a sort of interference pattern on these red dots you can see that are like wibbling around a little bit more.
I would say that the colours are slightly weird on that TV compared to all the other ones.
Right. Yes. Well, yeah. If you actually,
I mean on the screen.
On the actual TVs, yeah, because of the meta in the metaverse, the TV that's showing the TV that's got a picture of it. Whoa. Yeah. But yeah, so this is the PAL thing. So that's a fun journey to go down, because now I get to take the RGB signals, put them into a virtual PAL encoder, such as you would have on the BBC Micro, generate the sync pulses, do all of that kind of stuff, generate a huge high frequency like signal, such as you would get down your composite lead, and then immediately decode it and try and like turn it back into an RGB signal to put on the screen. And of course, because you're mixing and matching things, you get these fringes and the things that like go in and out of phase. I love this is my next video. I think I saw to you, Colin. Like, I really want to explain how PAL works because it's just a miracle that you can have one like you're a real engineer, so you're laughing. This is trivial child's play stuff, right? But yeah, to me, this is magic and. But, all right, let me go back. Oh no, let me go back. Oh, this is where I've now not. Oh, I've got my. Oh, that's opened a new one. That's why. Okay, there we go. Yes, all right. Phew, I've forgotten I'd told you to open the new window. Okay, so that's the new thing. That was fun. So JSbeeb turns up in a number of places. I think you've all seen BBC Micro. It's great that they're. And this is why I love open source because you start something and then before you know it, it's out of control and out of your control. And much smarter people than you are making it more accessible to people. BitShifters, obviously, if you've ever been to BitShifters' website and looked at anything there, then you can run most of the demos. I say most of them because again, there's a few that won't work inside JSbeeb. BBCMic.ro, which is the that's the BBC micropod. You've seen the little Twitter thing that so it's partly JSbeeb and partly they use BeebJit in the background for some of the things. And then sort of a follow on from that is the virtual BBC Micro. Which have you seen the virtual BBC Micro? Yeah, everyone's seen the virtual BBC Micro. That's so cool, though, isn't it? I mean, and in there isn't a PAL emulation, but who did the screen? Paul, yeah. So. If you zoom in on the thing, you can really see that someone's gone to town with these amazing graphics shapers that show the built of screen. What's it called? The mesh behind it. I mean, I tell you what, if only I could click it and see, and we could go and see what I mean. Did that work? Oh, this might actually blow my laptop up. Let's have a look. Loading click clacks. Yeah, so like if you it's back to Elite, of course. Isn't it bonkers, by the way, that my pedestrian middle, like 6-7-year-old laptop is not only streaming live video outwards, but it's also in JavaScript running an emulator that's now being projected onto the side of a 3D model. Okay, well, so if I could actually get it with a real mouse, this would work better. But like, you probably can't see it, but there's this beautiful color fringing and like these little hex like dots. Again, yeah, the people who are behind, but there's a lot of detail that's gone into making this look like the actual screen would have looked like if we were there. Okay, let's close that. Yes. All right. So JSbeeb's in a bunch of places. Excellent. And it was my first real internet fame. So I was on the register in 2014. Some kind of thing. I am a chap. And I rebuilt the BBC Micro, and what does it say? I think it says something about that. I think that the thing I cut out says something about Elite.
Did they still call you Godbolt?
No, apparently Mac they were able to spell my name correctly. It seems, which is good. Yeah.
Who wrote that story? I'm interested.
Oh, Simon Sharwood. I don't know. Does people know folks that registered the register? Yeah.
Well, at that point, several people at the register. High up on the register were ex-Rugon.
Oh, how funny!
The chief editor was an ex-Rugon.
Oh, that's funny. Oh, well, there you go.
People who ended up sleeping on my sofa when he was like, "Home, this is strange."
Oh, what a small
Yeah,
small world.
He's now left version. I think it's worked for Google.
Oh,
he left last year.
From Google to Google.
Yes.
It's an obvious. Oh, sorry. But no, this was my first thing. I think if I could get my Google Analytics, it was very obvious when this story broke because I went from like 10 views a day to hundreds of thousands over the period of like a few days, which was like, oh my God, I've really made it. How can I monetize it and turn it into... Okay. So, and then a sort of nod to this is me trying to tentatively find as many RISC OS based things as possible to try and make it sound like I do actually have a connection there. I noticed that Archimedes.live has, a thanks to me and the JSbeeb project for like showing that this kind of thing could be done. Although, this is what do I say? Although his is a WebAssembly port, so I don't know. To those of you who know anything about how web development is done these days, JavaScript is like the native, as in native to web, like scripting language, which just happens to then be very cleverly JIT compiled and whatever. WebAssembly is a sort of target for a compiler to emit. So you would write something in C or Go or Rust, and you can target WebAssembly. And it's a bit like real assembly. It's just it's a little bit more abstract and can fit into a web browser. It's awesome, and my my Spectrum emulator is written in C++ and is WebAssembly. So if you want to go and look at a Spectrum emulator, if you should feel bad, but if you do, you can go to SpecBolt or spectrum.godbolt, so .zania.org. I long ago I have to give up the Godbolt.org for reasons we'll get to in a bit. The ethos of JSbeeb was always, this is written in JavaScript because it was funny to me that it was fast enough to work. I did experiment with handwriting some WASM, which was the precursor to WebAssembly, where you just had to write a very, very specially formatted, careful piece of JavaScript that would still be valid JavaScript, but with enough like getting everything exactly in the right place, the web browser could look at it and go like, oh, I can optimize this a lot more. I can generate some faster code for it. That felt still like, well, this is still handwritten, but it was such a pain to write that I gave up on it. So I have been tempted to sort of like put in some WebAssembly into JSbeeb, but it feels against the theme of like you could just download it and point your browser and you have to install a whole bunch of things to get it to work. Although I guess that ship has sailed now with the packaging that I do. Anyway, doesn't matter. Right. I think we've seen enough of it, right? You know where it is, you know how to get it. I was demonstrating to the folks in the room who were here a bit earlier. I have this weekend been at a bug and added a whole bunch of new features into it, including the ability to rewind time. So if you're crap at games like I am, and you've just like blown up the last grenade in Exile, you can hit Alt page down and it will give you a nice list of all of the last like 10-second increments, and you can kind of rewind back to time when you had the grenade and then not blow it up in the wrong place. Just that, although it's very early days, and we've got save and load support in there as well. So if you want to actually save to a file, and I can import BM version 1 and version 3 snapshots as well, although I'm sure it's broken. Now, the cool thing about it being in JavaScript is that it's scriptable, which is kind of how the XR stuff all works. And so you can easily do arbitrary breakpoints. You know, like if you're a software developer and you know, once you've learned how to use your debugger and set breakpoints somewhere, you'll never really look back. You know, the first step is you put printfs everywhere, right? And you kind of like work out what your program's doing. Then you get tired of recompiling it and trying to put the printfs in the place where the problem actually is. And you learn to use the debugger and you put the breakpoint somewhere and then like, oh, but then how often have you wanted to be able to say like, I only want to stop at this instruction, but only when the A register is something, or only when the X register is something, or only when these 12 other memory addresses add up to some number. You can do that because effectively at every single instruction, you can run arbitrary JavaScript and decide if you want to stop there or not. So we can do things like, you know, simple breakpoints here is just like, sorry people at home, I'm pointing at a screen you can't see. I probably could point with a mouse button. There we are. Look, I can try and help us all. You know, this is just a JavaScript function that says, given an address, if that address is equal to FFEE, it would return true. So I can breakpoint if anyone tries to read FFEE. I can also like breakpoint on a position or a write. And, you know, I could do something where I don't breakpoint, but I run a bit of code. So I can just like keep a histogram of what kinds of instructions were being executed, or where was time being spent. I could like use like a poor man's profiler. So that's kind of a lot of fun. And certainly, again, when you're trying to debug a game and you're like, it crashes and it gets here with the address of, you know, with the A register being 27, and it should never be able to get to be 27, you can track backwards. So even before I had the rewind time thing, I had a circular buffer of the last 256 values of A, X, and Y. And that allowed me to kind of reverse time in a very trivial sense. But you could also do something more advanced with this. And certainly when you're trying to compare your emulator against someone else's, you can kind of output every single thing and then sit down with diff and kind of go, where did we diverge? And after 30,000 cycles, you're like, we didn't get the interrupt at the same cycle. Why is fun hit? Okay. Time for this other one. How am I doing on time? I'm doing all right, actually. You're not interrupting enough. Go on. It's distracting. I'm going to have a sip of beer while you all consider.
Someone in the chat did say they love Croc.
Oh, yeah, Croc. So Croc was a PlayStation title. In 1996, I started at Argonaut, and they didn't know what to do with me because they were trying to convince me to leave my degree to start as a programmer. But probably for the right reasons. I said, no, thank you, but can I still have a job? And they were like, okay. And they said, well, how about you come in the summer and you can learn what it's all about? But they had no idea what to do with me. So they handed me a controller and said, congratulations, you're a play tester. So I played Croc for the whole of my summer, which was great. There are far worse things to do in your summer job, right? The fun thing around then, it was like we just about realized that, a VHS machine was the best debugging aid in the world, because you'd sit there and you just record the game that you were playing, and then whenever something weird went wrong, you'd like note down the timestamp, and then you could talk. There's me talking about rewinding time and in emulator. It's like, they said, you said, oh, I'm actually getting him to fall through the wall here, and the Tony would come along and say, there's no way that you can get through the thing. And I'm like, okay, rewind tape. It's a great argument ender, which I guess flows into this. So, but then in '97, I joined Argonaut proper, and I was put on porting Croc, the team that ported Croc to the PC. So I was doing PC development, which was not really my cup of tea. I was one of those people who had my RISC PC with the evil inside sticker that looked like the Intel inside. I really hated Intel for whatever weird 20-something ideological reasons. And now I kind of find myself in the weird position of being one of the few folks who knows how to reverse engineer the Intel processors down to the kind of levels that we do for finance. So it's a funny old world. Yeah. So, how many people actually know what Compiler Explorer is? Okay, 2, 3, 4. Okay, a few people. Okay, so for the rest of you, this has stolen my name, because the site, in around about 2004, 2013, 2014. Oh gosh, I've forgotten now. Anyway, 2012 actually. 2012, after my stunning success and becoming internet famous on the register. Actually, no, it wasn't before that. Anyway, doesn't matter. We're getting the times here. I had an idea at work. We were arguing over some code-related things, and I wrote the world's simplest shell script-like version of keep running the compiler on a file and showing its output in a loop. So you just got this continuous replacement of what the compiler was doing, what assembly code the C compiler was generating. And then I split the view, and then using VI in the other window, I edited the file that it was continuously compiling. And then my boss was arguing with me about whether or not we could turn on some new-fangled C++ feature. And I was like, I really want to put it on because it makes the code more readable, it makes it more understandable, it's fab. But he was like, well, what if it slows it down? What if we can't now trade at the same speed, right? And we were profiling them side by side. It was like well within noise, but he's like, I just don't like it. I feel like it's going to gang up on us in some way. He wasn't wrong, because this is a tangent, but in Java, this particular thing does behind the scenes generate a tiny bit of garbage. And that in trading, if you're writing a trading system in Java, for a start, you're doing it wrong. But if you are, you're trying to not generate any garbage because you don't want the garbage collector to ever run. But this particular pattern, arrange for, causes a tiny bit of garbage to be generated every time you do it in Java. So it doesn't appear to be slow, but then 2 hours later, you do a garbage collector and the whole thing, the whole wall falls apart. So he was like, right to be suspicious, but the C++ equivalent doesn't do that. And I wanted to show him that. And, again, couldn't show him profile. So this shell script came out, and I went toggling backwards and forwards between using the old way and using the new way. And he could see that actually there was one instruction fewer in the new way. And like, okay, I think we can probably agree that they're at least the same, because the instructions are almost identical. In fact, it's probably one, and cycle counting is not perfect in just looking at the number of lines of code there are, but he could see that it was okay. And we adopted it, we used it in the rest of the code base, and we never really looked back. But what I was like, at the same time, I was learning how to write these simple web applications. You'd seen the Sega Master System thing, although that was not really much of a web application. But a friend of mine had showed me like how to hack together something quickly. I was like, well, do this. Why not run this shell script in a web browser and have a little thing that does the compile and shows you it more prettily? Because, terminals are great, but I do like a bit of web. And Compiler Explorer was born, although it was called GCC Explorer then because it was only GCC. Very quickly it became GCC and Clang, but I kept GCC. And I put it on my domain, my personal domain. So at this time we had bbc.godbolt.org. We had master.godbolt.org, which puts you in JSbeeb, but auto-selected master. We had, I don't think I had Miracle. Miracle's not a different thing. Anyway, but it doesn't matter. But I had a bunch of things. It was just my vanity domain. It's what my email was. And so gcc.godbolt.org went to GCC Explorer. a few years later, it was like, well, we've now got more than GCC, we've got more than C++ even. So let's just call it Compiler Explorer. It just explores the output of a compiler. You put code in, you compile it, you see what the compiler does, and it's very quick and interactive, and that's what people like about it. But I have it on compilerexplorer.com. Nobody uses this domain. Everyone uses this domain, which is where it lives now. Enough people have used this site without realizing that this is my name, that they just sort of backronym, or they infer that Godbolt must be some kind of like cool name that means something that explores compilers, or that you can kind of see it. I think Bolt is fast, lightning, God, I don't know, would let you see omnipotence, omniscience, right? And so then I turn up and people have started using it like a verb, right? Like to Google. So people will say, why don't we Godbolt this and see what comes out? Or let's put it in Godbolt and see what happens. And I'm like, I'm now at the stage in my career where I turn up at C++ committee meetings, and if I'm in the front row and they're like, let's put it in Godbolt, I'm like, I'm here. It's not called that. And so I did go on a big old rebranding exercise to actually make a compiler explorer across the board. But a friend took me to one side and said, look, if everyone is using your name to mean a cool website, you keep it. I'm like, it's fair. That's fair. Right, yeah, Twitter, exactly. Now, much like Google will never say Google for things, because they will devalue the I will never say this word. I will use Compiler Explorer, so that I'm not the person who's saying that that's okay. Despite my massive ego, that's a bridge too far for me. I actually got some. So as of this weekend, it now supports Archie SDK. So if you're using GCC 850 and Archie SDK to build any kind of RISC OS based things, then you can actually go and paste it in and see what happens. In fact, why don't we just, for those who haven't seen the site, let me just do this and zoom in. And this is going to give me real neck ache oh look, see, yay Kieran, this is me actually sending this to Kieran the other day. So here we are, this is what it looks like. On the left-hand side, you have your code, this is C. On the right-hand side, you have the ARM assembly that comes out of it. So, there's multiplying by squaring a number, and you can change oh gosh, sorry, it's hard to type at this angle. So if I get rid of that, it pretty quickly shows you the unoptimized version of the code, -01. We see whether or not it's already fully optimized at this point. What's not easy to see because of the stupid color scheme I've got it in. 1 second, please. This is what I run in this all the time because nobody else uses it. And if I don't run in this color scheme, then we don't notice when things break. So let's go dark. Yeah. Can't get there. Come on. Close. There we are. Oh, it's not doing it on here, of course. Oh, maybe that's broken with this. Let's assume that was working by me changing architecture to, oh no, look at that, it's even worse. The Z80 was the first one that it comes up with here. It's like it's haunting me. Right, I'm just going to pick ARM64 GCC control because that probably does work. Okay. Oh, it's not working as well as I'd like. Never do things that weren't scripted beforehand. All right, what I'm trying to show here is that you probably can't see there is a colored background here. I should probably go back to the light, and as I mouse over each of these, it's showing you where the code in each instance is, so in both directions. And the more optimized it is, the harder it is for the compiler to work out where the things actually came from. But it is a useful thing to be able to do. We have a million other features because it's been going for 14 years now, and it accumulates a lot of craft. But I'm absolutely thrilled to have been involved in its genesis, and it's mostly now a team effort from a whole bunch of other people. Because people have come up to us and this has changed the way that we develop the C++ language, because we can actually go and people will send me PRs to merge in their own versions of C++ that have speculative features they'd like to propose, and then they'll go to the committee and they'll say, here's my paper that explains that this is the new language feature I would like, and everyone strokes their beards, and they mostly do have beards, but perhaps the other table actually. And they say, do you have any implementation experience of this? And they go, yes, and they just all tab over to Compiler Explorer and say, you can all go and try it out now. This patched version of the compiler is available here. Drop this down, play around with it, or use one of the short links that then sort of explain. So that's really, really great to have. Used daily by many programmers. That's right. BBC's recently. Who knows who Tom Seven is? One person only. So you should go and look up Tom Seven's videos. He is an absolutely fantastic researcher at Google, lives in Pittsburgh, and makes the most ridiculous kinds of videos you've ever seen about the kinds of daftest things you might ever do. All very, very, very techy and all very, very in our respective wheelhouses, I would suggest. But I was absolutely flattered because Numberphile, who knows about Numberphile? Anyone else? Yes, a few more nods there. So Numberphile have been doing a thing for a while where every year they have a Secret Santa and they try and come up with an algorithm that's both fair, uncheatable, and anonymous without one person having to know everything, right? And that's one of those really difficult iron triangle cryptography things. And they invited me to be in it this year, and Tom ran it. And part of it was generate some random numbers for my algorithm in the silliest way you can. And so this is me explaining how my venerable BBC Master is going to use the random drive timings, seeking backwards and forwards between tracks on a real hard disk, real 5.25-inch disk, which, spoiler, it broke just before this, so I actually had to use my GoTech, but you know, smoke and mirrors. Explain, and I wrote a full Mersenne twister 32-bit algorithm in 6502. I was assisted by our friend Claude in writing a 6502 Mersenne twister algorithm, but it actually completely matches the C++ standard one, which was great. I generated 1,000 numbers on both of them. It takes quite a long time on a Beeb to do that, but that was a lot of fun, and it led me. This is my garden in Chicago, just before. I tweeted this to say, "Oh, I wonder what I'm up to," but it was a lot of fun, and it meant that I get to be in a video with Matt Parker and some other people that I've actually heard of and are really famous rather than just fake famous. So as we kind of come towards the hour, actually, oh my golly, you're gonna have to come with a lot of questions. I told you beforehand. What is the connecting thread amongst all of these things, right? So I was trying to think about what I picked up from a lifetime playing around with this kind of stuff, where this kind of stuff is for a large part BBC Micros, RISC OS, ARM, those kinds of bits and pieces, even if it isn't really now as much as it was. And it's like just understanding how computers work at the absolute low level has been totally part of what I have built my career on. There's nothing that's wrong with being an application developer. There's nothing wrong with being a physicist dealing with whatever. But like, being able to understand as a programmer the layers beneath you, I just think is really, really important. And now, obviously, practically, you have to kind of draw the line somewhere. I'm not a semiconductor expert, but my sort of rule of thumb is be comfortable in one level of abstraction, get by in the one beneath you, and know that the one beneath that exists. And then you're probably okay. You can always go 2 layers down. You've got some idea. So, like, I think for where I'm sitting is like, recently I've been looking at how ASICs get built, which is a fun thing to do. And I've just started to understand the kinds of incredibly weird analog problems that come up when you're dealing with that. And I'm like, okay. And then I started to move away back to my happy place of ones and zeros. But I think that's me understanding that like there is a layer beneath that, and it's great. And I'm glad there are people in this room who will appreciate and understand what it is so that I don't have to. Actually, yes, a fantastic thing. So this is really off topic, but I was once interviewing a hardware engineer, and he worked on the PHY. So the PHY is the physical like connection between devices. So on an Ethernet cable, the PHY is either the part that drives the laser and the demodulator on the other end, or for a copper thing, it's the part that drives the copper lines and their particular voltages and things like that. And and we were interested in that because we were making custom network hardware. And he said, "Oh, I work on the PHY for RAM chips." And I said, "Pardon? What?" And he said, "Oh yeah, I work on." So in fact, what I do is I do the delay lines that live on top of RAM chips. And I said, "What? I don't know what you're talking about." He said, "Well, take your average SIM DIM thing, right? You've got number of chips on the circuit board. It's about this big, and the kind of speeds that we're running these things at nowadays, a picosecond of delay difference between the 64th pin and the 0th pin is enough to cause the whole thing to go out of whack. So we need to have a chip that's forever tuning these tiny delay lines so that the bits come out at the same time." And I'm like, I've never thought of that as a source of error before in my program, and now I'm terrified that computers work at all, right? It's a miracle. So understanding the next level down is always fantastic. Yeah, I think it's fair to say that Beeb and the Archimedes taught me a lot of how that works. I mean, the relay bug this weekend, there was a guy, Dan, who had the book that I remember having as a kid, which was the Machine Code for Beginners, the Usborne book. I think I've done skits on this before, but like it was kind of almost emotional to see it again and be like, oh my God, I do remember being like starry-eyed looking at these robots going into pigeonholes and like moving numbers around and stuff. It's so emotive, and I still think about that now, right? You know,
Have you got the little book that you gave you?
I have. Oh yes, well done. Brian remembered, and it is still here because I'm trying to keep it flat. He has these tiny dioramas, and he gave me. Oh my God, I forgot. I didn't realize it actually had one on the inside. You can't see that there. Yeah, I don't know. For the people playing at home, that you just see a blob there. But what it is the tiniest printed out high definition machine code for beginners Usborne book that he put on his like little display that had a 3D printed BBC and a 3D printed Archimedes and all that kind of stuff. And then now it lives in my phone case because it's the only place that's going to remain flat while I'm here in the UK. He hopes. There we are. All right. So yes, the Beeb and the Archimedes were a big part of me learning about that kind of stuff, being interested in that, and obviously the people that I've met through that, yourselves included, yourselves back at home, right? The folks who know. You know, BBC Basic, I think, you know, there's a generation of programmers who, because you could open the square bracket and start typing assembly, you were off to the races, right? So, you know, again, I'm apologizing. The Sinclair Spectrum in my life was a games machine. I tried to program it, and I did program it, but only after I found someone who could give me a hooky copy of an assembler, because it didn't come with one. It was a natural, real, you know, it was a trick to assemble code. You know, there's only so many times you can type in data statements and assemble by hand. But the BBC Basic power, the fact that the assembler was there, the fact that it encouraged you to play around with stuff, and the fact that, you know, when it crashed, you just turned the thing on and off again, it was back to normal again. There was none of this kind of 84-hour boot. And I mean, like, you know, the Raspberry Pi is sort of the moral like successor. In fact, not even the moral. It's like it's the defined successor for that same reason. So it lets you play around with it still, which is kind of amazing. So its legacy lives on. RISC OS is clean design. I'm going to say clean. It's a beautiful piece of software. Its lack of any memory protection. Its lack of really any functioning operating system boundary at all, really, lets you do some amazingly cool things. I mean, you know, same kind of deal with you know, FinalLook et al. And I guess, yeah, that's quick. That was ended faster than I thought, because I thought we were going for longer, it enjoyed me a lot. But obviously, you know where I am. You know, there's things here. I've got a problem. Oh yeah, I've got some bonus photos, right? So this is what an American basement looks like. I'm sorry. This is obviously a power plant. So, but this is actually, if anyone's seen my talks that I do, like, elsewhere other than pubs, this is where I stand and I give my talk to a mythical audience that lives over here, and then the heating kicks on and I can hardly hear myself, and that's great because otherwise everyone else in my house can hear me through the heating ducts, right? But yeah, the reason I brought this up is there's my Sega Master System there, is that I do in fact have my RISC PC still and my 3010 there. So and as Richard pointed out, probably the source code to some of our games are on the hard disk that I should really get out of that machine. The battery did in fact leak, but it wasn't so bad that I couldn't clean out that area, and I have booted it up, but I now need to go back to it. Did I have any more bonus photos? Oh yeah, this is, so America doesn't really know what the BBC Micro is, but luckily there are some because it's rare, you go to, this is from VCF Midwest, which is the Vintage Computing Festival Midwest, and unfortunately, it was dead on this day. There was a sign on it that said something to that effect, but it was broken on that day. The power supply had gone or something. You know, that's the problem with weird voltages. But there are BBC Micros around and about, and a mutual friend of mine in Kieran's has a computer games museum, and he has quite a large collection of BBC paraphernalia. So we're trying to spread the word of the... and also on our side as well, like the BBC, you say BBC, everyone knows what the BBC is. But there you go, it's the British Broadcasting Company. You're like, no, it's not a company, but you're just happy that they knew that other countries existed, frankly. Sorry, Americans. Sorry. Now we're moving into the stand-up phrase of the BBC. So anyway, but yeah, the Sinclair Timex, of course, had a different name over there, and it's like Timex is a clock manufacturer or what? You know, it's some confusing. Sinclair, who's that? But you know, you can say BBC, people know what it is. Then you can tell them about the computer literacy project, and then you can sort of reel them in. And in fact, the gentleman who ran this display, he had the guy sitting there. In fact, he discovered it through the computer literacy project. He'd found like one of Fred what's his face's videos on YouTube, And he just watched them all, and he was like, "What is this? I have to know more." And so he ended up with the BBC Micro, amongst other things. So that's fantastic. Have I got any more? No, that is it. Okay, I'm going to go back now. Sorry, I threw those in at the end because I had them. And it seemed rude not to have some kind of American representation, even if I then throw them immediately under the bus. So please ask questions. What can we do about? Yeah, thank you. We've got any questions on the board over there?
There is one's just come in, which is the love your advent of compiler optimizations. Will you be doing it again?
Colin and I just shared a look then for those who aren't in the room. I'd love to. So my personal situation was when I finished at my previous trading company, due to interesting and fun contractual reasons, I was unable to start work at my new trading company for a whole calendar year, which was wonderful because I was not left out of pocket because of this, but they would just pay me not to work, which is great. Which meant I had all the time in the world, and in all the time in the world, of course, I replanted the garden, I repainted the house. No, of course I didn't. I was spending all the time on Compiler Explorer and doing things like the advent of code, which is great, advent of compiler optimization. So it is a ton of work. Colin and I were actually talking about this only this weekend. There is a lot of work that goes into this. You think it doesn't take very long. You do like a 10-minute video, but it's a long while. It takes about 8 hours, I reckon, per episode. And, there are 25 of them. So it's kind of a lot of time. It's like a whole month and a half, 6 weeks of work. That is writing the blog post that's behind it that actually has like the real teeth to it, the actual like, this is how this happened. Usually finding bugs in the compilers when you're doing it, and you're like, at least 2 days, I'm like, oh, the compiler will do this trivial optimization, of course, and then it doesn't. And you're like, but why? And then it takes you 3 days, and then you file 3 GCC bugs, and they're like, this is stupid. And then you get the GCC devs working, which is great. So everyone's a winner. But then you record it to camera, you write some kind of a script, you record it to camera, and it takes, 10 minutes of video takes maybe 20 minutes to record if you're very good at it. And then you're staring at 20 minutes worth of yourself, which is like the worst thing to see, and all of your ums and ers and scratching your nose and smacking your lips and all of those things. And so it does take a long old time. And then especially if you get carried away, you're like, I could read with an on-screen graphic here. And you're like, well, there goes another 4 hours because I'm not an expert. So the short answer is probably not. I have some hopes of making some microarchitecture sort of short bites. I think everyone liked the fact that they were, so I don't know if just talking about something that people might not know what it is. I did a bunch of like 5-10 minute videos, like Colin, inspired in fact by Colin's advent. So that it was like a daily dose of here's a cool thing compilers do, ha ha ha, right? And it was great. Other than here's a crap game. I'm not going to repeat that for them. You're underselling yourself, Colin. So I'd like to do more of them. I think everyone likes the small bite-sized content. I think it's just about, walk to the train station rather than like, I love that there's long-form content out on the internet. There's like some amazing things like Veritasium. I'm sure most of you know who Veritasium is. They've started doing like hour-long videos and stuff, and they're really deep dive and they're incredibly high production value and everything. And I don't have the time to watch them anymore. And it's a shame. They're all queued up, and thankfully I have like an 8-hour plane flight coming up, so I've got to get through a few more of them in that period. But other than that, it's hard to digest. So getting these, I'm never going to do the YouTube short thing. I don't think that you can get anything meaningful in that. Although I have a friend who tries to do it. But yeah, so probably not. But I'm hoping it will come back in some other form as like some amount of short form content, maybe once a week, once every 2 weeks, something like that at some point. Specifically for microarchitecture, which is like my favorite thing to talk about other than this and other than all the stuff. So thank you for the question.
That was Jeff, funny enough.
Oh, yeah, me old mucker. Yeah. Thank you, mate.
If you start recording now, you might just about get an audience for advert.
That's a good point, But yeah, so for those outside, Colin said if I started now, I might just be ready for advent again. Yeah, at the rate I'll be able to do it rather than the time when you've got dedicated time and your family. And also, yeah, that's the other thing is recording time with a family of teenagers and dogs and things is it's precious time. Luckily, I'm a morning person, so I'd often get up and then do it before anyone else got up. But then you've got lighting, and then you're like, what has become of me? And I'm setting up like these ring lights and things, and I'm like, my camera is here, and my backup camera's over here, and I'm like, oh, geez, what happened? That took a wrong turn. Fantastic. Any other questions?
Have you got your kids into it as well?
Have I got my kids into it?
Oh man.
Yeah, no, they have willfully tried to not follow him off my footsteps. They're tech literate, they're more than, I like to think they're more than average tech literate, not interested in programming because I've tried to make them interested in programming. So of course, it's not cool if dad wants you to do it, right? That's not okay. The elder kid is ultimately has ended up wanting to do nuclear engineering, which is not a million miles from the quantum physics that I was doing. But I think he's been able to convince himself that that's not what dad did. It's completely different, except that it's the same, right? The younger one is probably more likely to get into it, but his dad currently wants to be a nurse, which I'm like, great, I work in finance. So in fact, if you can be a nurse, there's some karmic balance in the world about that. But that's probably getting a bit too political. But no, they're not that interested, unfortunately. My nephew, on the other hand, just started asking me questions. I'm like, there's a hope here. Maybe I've got another chance. Maybe there's another chance. And it's certainly weird. The rest of my family has no idea that people use Argonaut. But they kind of do, though, because I've sort of mentioned it. But I was watching Laurie Wired. Does anyone know Laurie Wired? YouTube channel. Yeah, there's a Faye nodding over there, but she does a whole bunch of computer security related stuff, amongst other things. Very bright girl. She's very, very good at delivering understandable content, unlike me, because I can't even fit my words right. But I was watching one of her videos on the main telly, and then she brought up Compiler Explorer, and of course she called it the other name. And my wife is in the other room, is not really listening, but obviously if you hear your own name, she's like, "What did you just say?" And I'm like, "Oh," and so she goes, "What? They actually used that? I told you this." And it's like the first time she actually experienced it in real life. So it's odd. And my son obviously, they all Google each other, and obviously if you Google the name, you end up with that. So that is weird. It is very weird. And it is weird to be recognized as well. So I've just started a new job at a new company, and this is the first time I've ever gone to a company, and I'm introducing myself to these engineers. I say, "Hi, I'm Matt. It's nice to meet you." I say, "We know who you are." Like, oh, who'd have thought? The consequences of my own actions, eh? So it's a bit odd, but it certainly makes me feel like I've got something to live up to. But yeah.
How did Compiler Explorer go from being a new project to being a team of people?
So so the question was, how did Compiler Explorer go from just being me to a team? Slowly. In fact, it languished for a very, very long time. It was like 4 or 5 years that it was just running on a single Docker instance on AWS. I've got a whole dog and pony show about how the whole thing works, which is more complicated than you'd ever want to know about because it grew. But yeah, so for about 5 years, it was me paying for it for myself, and mostly, it's on GitHub, so people find it and they sometimes send little things and whatnot. Then a person from Spain started helping out quite a lot, and I invited them to be a full committer, and then we got another couple of people come on board, and then those have been the real solid people who still commit to the code base. And eventually we got to the point where I'm like, I think I trust you enough. Here's the Amazon credentials. Please don't break it for the whole world. It's kind of a responsibility. It's people use the site daily, and it's I'm knock on wood. It's been relatively reliable. I was giving a presentation at work only last week about it, and the current uptime again. I think we're 7 years into not having an outage on the main top level site, but in fairness, that's just because CloudFront serves that bit, so we're that's cheating. But we go for many months without losing even a minute's worth of downtime on any of the endpoints that we care about and monitor, which is really cool for a bunch of individuals. So yeah, organically is the short answer to that. People have come and gone. I would recommend, if you are trying to hire smart engineers, you have a high profile open source project, because then you get these people who are in undergrad or in other jobs, non-traditional jobs that are just interested, just like we all were at computers, and they sort of self-select. So I was doing a live stream during COVID, and a very smart person joined joined the chat and was sending comments while I was trying to do some of our sandboxing. As you can imagine, probably running other people's code on your computer is a bit of a nightmare, and you don't really want to let them do arbitrary things. So I was trying to lock down our sandbox, and this person was giving me these great answers, and I was like, "Oh, this is great." And eventually we started emailing, and then eventually he became a committer, and then I met him at a C++ conference, and I'm like, this sysadmin from like a material science company in the middle of Nowheresville, upstate New York, this guy's smart. We should hire this guy. And so it took a little while because COVID was still bouncing up and down. But about 3 years later, we finally got him in as a full-time employee, and he was like the best hire we've ever made in that company. In fact, he's just starting at my new company because he's been able to find a way to work together again. And so that's great. We similarly, the Spanish contributor was looking for a job out of university, and I was able to write a glowing recommendation to a couple of places, and ultimately they got a job at one of those two. I'm not saying it's like me, but like, no, it's something you can hold up to. And then a new grad about a year and a half ago joined our company because he was also a committer. So it's a great way of finding amazing talent that we would not normally have picked up on, especially, Austin was fab. As soon as you talk to me, like, you are wasted, right? This guy used to hack PlayStation 4 and PlayStation 5 hardware, right, as a hobby. So, what are you doing? But you can't get out of that situation if you haven't got the right degree, you haven't got the right college, you haven't got the right thing. So, but like, it filters it. So that was a great explanation. That's a very long answer to not the question you really asked, but organically and slowly, and that's question at the end.
That's energy use is a hot topic now. Missed optimizations mean like kills. Megawatts. Do compiler developers use Compiler Explorer to pick up on other people's optimizations they missed? This user that never reaches you.
Oh, interesting. No. So the question, just for the folks at home, is energy usage is a big deal these days, and do compiler optimizers use Compiler Explorer, what people do on Compiler Explorer, to help them understand what's going on? I do know that many compiler authors use Compiler Explorer. Like every third bug tracker has a link to compilers with that sort of, it shows a compiler bug, so it exercises the issue, right? It's a kind of, works on my machine, doesn't work on my machine, like this is someone else's machine and all that. So they use it for that, and for the same thing with I don't know, I'm looking at you, I think I was looking your way when I talked about it before, like the committee members use it to put their like upcoming things in. I've had computer security researchers reach out to me and say, hey, here are some buggy bits of code that we know exist. Can we run, because I have like 3,500 or more than that compilers now that you can access really, really, really easily without having to install the 4 terabytes that it represents. Can we use your REST API and just try each of these in turn and see what each compiler does with it so that we can teach an engine to look for vulnerable code? And I'm like, yes, you can. So that has happened. We don't share very much information about what people send to us. We've got quite a comprehensive privacy policy about what we do and don't do. There are some very high-level aggregate statistics that let me see who's using what compilers, what flags are being used. But even those, it's a landmine, like you can imagine like some secret project, you have a dash capital D, some code name equals something, you're like, that's possibly IP? I don't know. So I have to filter out that, and I'd go through a big list of like, which flags can we reasonably keep and not leak information? The code is never saved unless you make a short link and then it's saved somewhere, but I can't get to it without knowing what the stupid link is. Pit as a comment thing, and we never delete them. Those are short things. I don't know of anyone specifically using it for energy usage, but of course someone could come to me. I'm pretty open with it and say how many people are compiling with like OG for like, debuggable or whatever versus O3, which blows out the code and maybe is more power inefficient. No, but it's a really interesting thought. Yeah, no, yeah. Good question. Anyone else? Going once? No. Yeah, come on. Yeah.
What was it like getting a well-known commercial added to Compiler Explorer?
We're still recording, aren't we? It was a difficult process when you're an individual trying to sign an agreement with a large multinational company that has quite a lot of bureaucracy. The Compiler Explorer LLC that I now own and operate as a sole proprietor exists purely as the one and only defense between me and the end user license agreement that Compiler Explorer LLC signed with a large multinational company, so that I've got some hope of it. Without getting into this, right? So Microsoft's compiler, we went through a process with them. For the longest time, they wouldn't let us run the compiler because their end user license agreement doesn't let us. And they ran it on their own infrastructure, which frankly, to start with was like, This is brilliant. You're paying for it. You're running it. It's your security problem. Ha 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 ha. Right? Whatever. And for weird historical reasons, Compiler Explorer has always supported this sort of cascading idea of like, we can proxy for another instance of Compiler Explorer. So you have like our front end, and then we configure it like, and another source of compilers is Compiler Explorer.ms, which is where it actually went to. And it's like, okay, and so when we start up, we fetch whatever compilers they've got and we add it to our list. Then if you ask us to compile, we go, I don't know how to do this, you do it, and we present. So that's great, right? It's lucky that we had that in the bag when they came along. All right. Although that's a whole other thing. And then unfortunately, when you're not in control of something, it's hard to give your users a good experience without accidentally, as I'm choosing my words carefully, ruining the relationship you have with the other company, because you don't want to say, our servers are up and working fine, thank you very much, and our uptime has been 7 years. Unfortunately, a large multinational company is unable to keep a small Node.js application up and running on Windows for more than a couple of days without it going down. And us having to email them. And we're the first person to tell them after 2 weeks of it, that kind of feel. Right, okay, now I'm sorry. We don't have to edit that, I'm fine with it, it's good story. But it was a bit like that. And and in fairness, the SREs I was talking to on their side were equally as frustrated, but they were hamstrung by a large organization and what they were doing. And eventually they had to do a security audit, and it turned out to be like, you're doing what? You're running someone else's JavaScript code that you just download off the internet without really checking, that is my code, on Microsoft servers that then allows arbitrary people on the internet to compile and run their code on ARM. No, no, they tried to fly it under the radar, and we'd advised them, and everyone knew about it was a bomb. Once the security people got it, so at that point we finally had to get an amendment to the end user license agreement to allow me to host and run and present the output of the compiler to other people, because there is a specific clause in the EULA for MSDC that says you can't do this, you can't provide our compiler to other people as a service, because this is the AWS clause, right? Like, hey, this is great and it's free, you can use it wherever you like, but you can't be Amazon and sell it to other people, which is fair and fine, right? So we got through that was fine. For Intel, for their compiler, it was just like one of their engineers said, oh, I can send you a copy of it, it'll be fine. And I said, as long as I have an email from you, from your Intel account saying it's fine, we're good. And then I said, oh, there's all this license server stuff. He said, all right, so we just take that out for you. It's like, license. And it's like, it's a funny window into the world again. I've been living in this open source world for so long that I just take for granted that everyone open sources their software. And this was 10 years ago, so to take it with a pinch of salt and all that. But Intel were like, well, we spend all this time working on this compiler, and we make it, and we do want to give it away. We want people to use it because then we'll use our chips more because it specializes for our chips. And there's some other things that we don't like about what they do, but whatever. But the management feel that if we give it away, people won't value it. So we have to sell it to people, even though we'll immediately, as engineers, tell them, if you've bought a copy of it, this is how you disable the license check, so you can put it in your CI system and whatever. This is so stupid. This is so daft. So that's Intel. We've got a few other commercial compilers there. Most of those are gentlemen's agreements, I suppose, is the best way to put it. But the Microsoft one was very much that. And I'm blessed that I married a lawyer. Now, she's a lawyer in Britain, which doesn't help me in multinational company, but it's useful to have a good pair of eyes on a document that you're signing away. And she was the one who said, I don't think Matt Godbolt should sign this. I think Compiler Explorer should. Fine. Fair point. Fair point, Ness. Yeah, good questions.
Do you accept bug reports?
Do I accept bug reports?
The only reason I say this is I think is 6502 compiler and Compiler Explorer isn't working.
The 6502 compiler is broken. That I do. I have accepted that. But by preference, if you can go to GitHub and put it on there, or I'll try and remember after this meeting. And if you can save a short URL, because people do this, they'll send screenshots and things. And I'm like, there's a button at the top that says, give me a URL that exactly reproduces where I am now.
You should follow the button before you were sent that stuff.
Oh, there you go.
Yeah, I tried to do something with Fire, it didn't work.
Yeah. Right.
If your software meant to crash, you have to go vulnerable value.
Oh, did you? But no, we have quite a lot. It's the bane of my life. I mean, I know we've sort of segued into, and I apologise to those folks who are not Compiler Explorer centric people. Well, hopefully it's interesting enough that you're not dying of boredom. But it's a significant enough project. It cost me well, it costs Compiler Explorer LLC about 50 grand a year to run, so it's not cheap. We do have commercial sponsors, which I try and keep as absolutely negligibly just a few pixels at the top as possible. We do have patrons. I do sell merch. I have put some of the YouTube revenue towards it, not all of it. Some of it I think that's me doing it. This is me now. I'll tout Compiler Explorer Monks, and that's obviously a Compiler Explorer Monks, and fair enough. But like my YouTube revenue, all tens of pounds of revenue. Yeah, Colin well knows. But it's by any measure, it's a funny, tiny little business, right? And where was I going with this? I forget now. Hold on. Bug reports. Yes. And so, because I have patrons who are like just engineers who say, yes, I'd like to give you $1, $5, $10, $50. Any more? Any higher than that? $50 a month or whatever, which people do, and I'm incredibly grateful. I do feel a sort of moral obligation to do work on it, and that means that, I have a fairly full-on job. I have my hobby stuff that I like to do, and I have Compiler Explorer, which is no longer, unfortunately, stuff I like to do. It's stuff I feel I have to do. And it's a bit of a sadness that when a hobby gets to that level, it's like a small business. And obviously I do enjoy it. It's fun, but it's like, I don't go, oh, I'm excited to go and fix the 852 open issues in Compiler Explorer, most of which are like funny little things that people are like, you had my funny X compiler or my Y compiler. I'm like, look, there's a README that tells you how to do it. I've tried to make it self-serve as possible. So that is where I am with that. And thing I've been experimenting with recently, and I'm sort of reluctant to sort of out to myself like this, but I've already mentioned my friend Claude that helped me do my Merced Twister. But some of those issues are perfect for AI because they are very self-contained. This is the README that says how to add a compiler. You need to make a pull request that looks like this. You have to wait for it to build. When it builds, if there's a compiler error, it's almost always like some typo that you just have to fix. And you do it 2 or 3 times, you get the answer, and then you send me the pull request. And now I click the button, and now it's on the site. And so that kind of thing can be automated quite well because it's almost automatable now. It's just, it isn't quite automatable. And so that has helped me get the bugs list down recently and even triage them. So that's been interesting for me, but it is, it's a double-edged sword, right? I'm trying to be effective with my time, but it's expensive both in terms of actual cost of me and one can argue societal and power and all the other things to your point in the corner about power management, like that kind of ship is sailing at the moment. But it almost feels like, well, if I don't have something to help me, then I'm never going to catch up. So I don't know. There you are. There's a nuanced-ish opinion about what I'm doing there. It's difficult to talk about these things really. Any other questions?
I know you said the Archimedes live in WebAssembly.
Yes.
JSbeeb, lots of JavaScript. What's the kind of benefit of one over the other? Is there a good reason like JSbeeb WebAssembly? Will there be benefit to that?
So the question in the room was, WebAssembly versus JavaScript. Just discuss, kind of, right? Yeah. So WebAssembly is very much like what the JVM was supposed to be. It's like no one will write it ever. You don't write JVM bytecode. You write Java or you write Scala or whatever other languages, and it compiles to this thing. And this intermediate representation is close enough to what most computers do most of the time that it's trivial to turn that into actual object code when you need it at the end. So it does have types. It knows it's a 32-bit number or a 64-bit number or whatever, that kind of feel. More importantly for web-based stuff, it's obvious where the bounds checks need to go to prevent malicious code from getting outside of it. So there is a way that you can prove that a WebAssembly batch is not harmful to you, and then you can generate assembly code from it, knowing that where the checks have to go, and then that's the only place they have to go, right? Which is great, right? So think of it as like a sort of pre-optimized thing. But it's not its own. You couldn't really write it on your own. It's not even like assembly code. It's a very weird and wonderful thing. It's more like GCC's intermediate language, which I'm sure some people can write. I can't. Whereas, and so you get some benefits from that. Obviously, in principle, the compiler can work. Sorry, the browser can prove that it's safe, optimize the heck out of it, and have it run almost as fast as machine code for the computer that you're on, be it an ARM machine or an x86 machine, or I know that some embedded systems are going this way because you can prove some things about it. So, if you're going to take a code drop, if you're a Toyota and you've got to get a new brake disc controller code, you get a blob of C that you can't look at, or they probably don't want to share C with you. They want to give you the object code. You're like, well, I can't deal with this. They can give you a WebAssembly thing, and you can go, well, at least I can prove that this won't read outside of the memory that it's allocated. So it's good, right? JavaScript, on the other hand, is just convenient, human writable language that can, with an awful lot, I don't know, hundreds and hundreds of years of engineer effort, be turned into an internal representation, which is not a million miles from what WebAssembly already is, but with a whole bunch of caveats. So JavaScript is completely dynamic. You can concatenate two strings together and then evaluate it as JavaScript, right? Just like eval string in BASIC, right? So you can do some really, really bonkers stuff. You can't do that in WebAssembly in the same way. And it's the scope in which you can interact with the WebAssembly is very limited. The way that you can talk to the DOM, like the actual web page itself. So, for example, an emulator is perfect. Take care. Nice to meet you. I will bump into you in the barley mow sometime. All right, our other people are leaving over here, so we'll let some folks. Take care. Thanks a lot. So if you need to do a lot of web page things, JavaScript is still probably the best choice because you can just directly reach out and like grab an HTML element and do something with it. With WebAssembly, it's more like a very thin API you can call to do some like computational work for you, and you can give it a few handles to the outside world, but any interactions it has with the outside world are through those handles. So an emulator is perfect for this because you say, here's a blob of code and 64K of bytes. I'm going to write, there's two functions inside of you. One of you is emulate some number of instructions, and I can call that for my JavaScript, and it goes away and does some really fast stuff. And the other one is like, where the hell's the video memory? And I can ask it where the video memory is, and then I can reach into its little memory space, suck out the video memory and draw it to the screen. That's amazing, right? All the bits that interact with the browser are just the dumb bits, and then the fast bit is essentially as fast as if I'd compiled it in C. Ish. So hopefully that answers some flavour of the question. Anything else on the line? On the line? Oh dear. I'll have to drink some more of this. 0%, so it's not really going to help me in either one.
No more questions, I don't.
No, all right.
So you get to have a break.
I think I get to have a break. I've been talking now for an hour and a half. Thank you all for coming. It's been really fun. I liked it. Thank you very much.